Hey everyone, I'm going to share with you, my powerful way of doing completing the square. And I guess it's actually some kind of original work. And I keep it as a secret for around like 10 years or so. So I guess I just want to see how many people, just think like what I do. But I can't search for any similar materials. But actually, I'm intrigued by the US International Mathematical Olympiad, the IMO coach, Dr. Po-Shen Loh. He made a movie about his new style of doing the continuous square. So, but then my way of thinking have some similarity to his method. But then there is a large part which is quite different from what he is thinking. At the least, I do not use the sum and product roots about the quadratic the relationships between the coefficients of the quadratic formula. And so let me just illustrate it and see how you guys think about this method. And I just illustrated it by some example first. Then I'll show you the whole process of how I get the answer. So let me have the first step. This is the first example, x squared minus 8x plus 5. Then I just take the x out for whatever reason. Because there may be some teachers teaching you, wow, don't leave the last term, don't leave the constant term out. Because when you're doing factorization, then you can't leave something out without considering the last term. But then I just ignore them because I want to have my original way of doing completing square, so I just don't care about other stuff. And actually, the traditional way of doing the completing square, they just don't treat the plus 5 as something that you have to consider. You just consider the first two terms. So what's the next step? My next step is to consider this x times x minus 8. How can I turn it into some square stuff? How? So a magic formula, popped up in my mind. This is the a minus b times a plus b equals a squared minus b squared. I guess there are some countries' curriculum, including this formula as one of the must-learn materials in the curriculum. I'm from Hong Kong, and then this thing is from some kind of like grade 8 materials. So how can I use this formula? Okay, maybe I shouldn't assume every one of you is so brilliant. So I try to prove this formula for you first. We expand the brackets, and then we get that this is a squared, then a times positive b is plus ab, then minus b times a minus ba, then minus b times positive b, that's minus b squared, and then the middle terms cancelled out. So I guess I proved the result. That's a squared minus b squared. So the result follows. And how can I, the next step we should figure out what's the relationship between the four terms here. The four terms I'm referring to is the a minus b, the a plus b, and the a and b. They are four guys. But then I want to interpret the real meaning between these four terms. If I don't get the real meaning between these four terms, then it's only some messy algebra, and I don't want to do messy algebra at all. So if you know some kind of algebra, then you can figure out that the a equals the average of these two numbers. If we consider a minus b is the first number, and then this a plus b is the second number, then the a is the average of the two. So I can explain a bit. You got a minus b here, and then you got a plus b here. If I add the two numbers together, then the b cancels out, and then what's left is the 2a, and we have to divide it by 2 to get a. So what is the effect of these two steps? We add the two numbers together, and then we divide it by 2. So actually, this is taking the average. Add two numbers together and divide by 2 is the average. So how about the b? The b we are doing somewhat the same steps, but then we are not doing addition. We're doing the difference between the second and the first number. So if we do the difference between a plus b and a minus b, that's 2b. The a cancelled out, and then we have to divide it by 2 to get b. So this is difference divided by 2. All right. Yes, I guess it's the flow is all right. But then if you are not that familiar, if you are not that familiar with with the algebra stuff, then I give you some visualize stuff. I can visualize this four guys with a number line. Okay, let's stick it with the a first. If I add b to this a, that means we have to move b units to the right, and then we get this a plus b. Move b units to the right. How about a minus b? We move b units to the left from a, and we get a minus b here. So these are the four guys, a minus b and a plus b as the first and second number, and then b as both the distance. So I guess you can see that the total distance is 2b. So halfway through, it is difference divided by 2. So this is difference divided by 2. So we can verify from this that the b is difference divided by 2. How about the a? How about the a? The a, you can see that it is in the midway between a minus b and a plus b. So in the geometric meaning, it is the average of the two. So you can see that what we have done in the algebra stuff matches with what I have done in the the number line thing. Average, yes, this is average, and this is difference divided by 2. So this is the only single formula that is reliable for me to move on with the next steps, and I don't have to need more formula for for my derivation of my result. So how can I apply my my theory to this x times x minus 8? Let me do it for you. First step, we consider this x minus 8 as the first number, and then x as the second number. Okay, if you don't get it, I can still put it in the number line, and you can see what's going on. So I put it in the number line, and then x is here, and x minus 8 is on the left. So this is the first number, and this is the second number. And it should be in the, it is to replace the a minus b thing in the formula. And this x represents a plus b. How about the a? How about the a? The a should be in the midway, and so it is the average of x minus 8 and x. So if you can see x as something like x minus 0, because when you minus 0, then it's doing nothing to x. And you can see that this middle number is x minus 4. How can I get the 4? It's just, I just derive it like this. Like the first number, you got an x, and then the second number, you got an x too. So I guess the middle number should have an x here. And then I take the average of 8 and 0, and it's going to be 4. 8 plus 0 over 2 is 4. Okay? This is the middle number, x minus 4. How about the b? How about the b? This is the a thing. The x minus 4 should correspond to the a. How about b? How about b? The b should be this distance. But then you can see that we can get the distance super easily because we have this x minus 0 and x minus 8. What is the distance between x minus 0 and x minus 8? The x is not important. We can just, super intuitively see that the minus 0 and minus 8, the difference is 8. And then we divided it by 2, then it is 8 minus 0 over 2, and it's 4. The distance is easily, we can easily get it for it. So in total, we can make this x minus h times h minus 8 minus 8 to be a squared. What is the a? A is x minus 4 squared, and then minus b squared. The b is 4, so it is 4 squared plus 5. The 5 we copied it to the to this new term. So we have already done the whole computing the square, the steps. X minus 4 squared minus 16 plus 5, then whole thing becomes x minus 4 squared minus 11, and we're done. Okay. So let's review what we have done and why we get the final result. The main reason is the first guy got an x inside, and then the second guy, we don't have any x. Why are you so sure about this step? Why are you so sure that the first thing got an x, and then the distance, the b, don't have an x? You can see from here that the middle number should have an x because we have just explained it. The first number got an x, and then the second number got an x, and then we take the average, so we should have something like x plus something or x minus something. So I guess it's x minus something. It's x minus 8 and x minus 0. And then the 4, we get it by 8 over 2. 8 over 2. Also, the distance is also 8 over 2. Why is it so? Why is there a coincidence? It's because there's a 0 here. No matter when you are doing the average, you do it 8 plus 0 over 2, or you get the distance 8 minus 0 over 2. No matter you are doing 8 plus 0 or 8 minus 0, you do nothing to the 8. So we get the same number. So how about other expressions? Maybe you are only getting lucky this time, but how about other expressions? Let's do a bunch of questions before we draw some conclusion. So how about we do x squared plus 10x minus 11, and how about like x squared minus 5x plus 10? Okay, let's do one more. How about like x squared plus how much 13x minus 5? We do three, and we want to draw some conclusions out of these 3 examples. So let's do it. First step, we take the x out. And we get x plus 10, and then minus 11, and then we draw another line here, and we get x plus 10. How about a and b? We get a is the middle. It's in the middle, so it's like x plus something. What is the something here? It is 10 over 2. Why? Because it is x plus 0 here, and then it's x plus 10 here, and then we get 0 and 10 halfway through, we get 10 over 2, and then how about the distance here? Total distance is easy to get, like 10, and then how about halfway through, it is 10 over 2 again. So I'm telling you that these 2 numbers always match, And so we can see that if we apply that a squared minus b squared stuff, then this thing turns into 2 the difference between two squares. It is the a term is x plus 5 and the squared, and the b term is 5, so it is minus 5 squared, and then we copy the minus 11 here. So in total, we got x plus 5 whole squared, that is the competing square term, and then the minus 25 and minus 11 is kind of a trash, and we get an answer. This is it. How about something we cannot take out, like this one? The 5 is not an even number. How can we do with it? It is actually the same. We take out the x and then x minus 5 here and then plus 10. So how about we do a number here? We have this is x, this is x minus 5. Although sometimes if you are dealing with minus here, then you are in the left on the left of x, but then when you're doing plus here in this example, then you are on the right of x. But then it's almost the same. The difference is just a sign. Sometimes it's minus, sometimes it's plus. But we don't really care because it's so easy to derive the result. Because how can we get a? Same. We get the midway. We get the midpoint of x and x minus 5. So both have x, so we have an x, and then this one is minus 0, so 5 and 0, we take the average, that is minus 5 over 2, And it doesn't matter if we cannot, divide 5 by 2. If 5 is not divisible by 2, that's not a big thing. How about this, the difference? The difference is 5, and halfway through, 5 over 2 again, the same number appears again. So we get this as a squared. A is x minus 5 over 2 squared, and then minus the b squared, 5 over 2 squared, plus 10. Okay? I guess you can feel how we do it. We always have the same steps, and we always got the answer right away. And the first term is the competing square term, and the last two terms are trashy. So we get it as this guy is 25 over 4 minus and plus 10. Then all in all, we get this as plus 15 over 4. Okay, so we do the competing square, work. One more example, and then we jump to another, harder example. When we're doing x squared minus plus 13x minus 5, then we, take out x, do the same thing, minus 5, and then, x plus 13, midway through is x plus 13 over 2, and then half of this is, halfway through is 13 over 2 again. And so we have a squared, a is this thing, and then b is this thing, and then it is like a squared minus b squared, and then copy trashy stuff, minus 5, and we get an answer. We get an answer. Minus 169 over 4, and the last result is follows. Oh, what's going on? Yeah, the last result is just some random calculation. And I guess I illustrate the main part of my theory. My theory is that if you just take the x outside and then we apply that a squared minus b squared very magical formula, then we get the result right away. And yeah, that is what I think, and I guess it is super intuitive. And how about if there is a term outside? How about if the x squared term is not 1x squared, it's 2x squared or more, like 2x squared plus 5x minus 9, something like that? Then we can just take 2x out, and we have something like this. Because you have to, divide the 5x by 2x, and you get 5 over 2. And we ignore the 2. We just leave the 2 outside, and we consider this thing as one term. And we do the same thing on the middle, everything in the middle bracket. Okay, so we have this x in the line, and then x plus 5 over 2 here. And of course, the important thing is the middle point and the halfway distance. And so this is the x plus 5 over 4, and then this halfway distance is 5 over 4 again. And so it's easy. 2 times that's a squared minus b squared minus 9. Of course, you have to be careful of the brackets, and you will get this if you expand it out. And it's minus this 2 times minus this guy, and then you have what, like 25 over 8, and then minus 9. So at the end, you get this. The important thing is this thing, this completing square thing. I don't care about the tracing terms. All the constant terms, all the numbers out there in the back is just some nonsense stuff. I don't care about all this stuff. So the final answer is something like 97 minus 97 over 8. Yes, and that's how I do the competing square stuff. How about how can I generalize it? How can I if I replace the numbers by ABC, how can I do it in the how can I derive the quadratic formula to be exact? So how about this? Like ax squared plus bx plus c. If we equal 0 here, yeah. How can we do this? We just divide it by a. Then we can make sure that the x squared term is 1x squared instead of something x squared, and then it's b over ax, and then it's c over a equals 0, and then we do what we have done so far. So after that, I don't care about the plus or minus sign here. I don't care about if it is really a I don't care the position of this guy and this guy. Actually, you can be the b over a term can be negative, but then as we are just illustrating it by the number line, then I don't care. I just give you a visual way of doing this problem. So we do the same steps as before. The midpoint, the midway point is x plus something. What is the something? It is b over 2a. Okay, you can see that this is x plus 0, and this is x plus b over a. So midway through, this is this number divided by 2, so it is b over 2a. How about the distance, the halfway distance? The halfway distance is the same as the b over 2a, so it's b over 2a again. So by that a squared minus b squared thing, we have this is the a that we were talking before, and minus b squared. This is the new b squared. Okay. So all in all, we can throw every treasury terms back and throw it to the right hand side, and we get x plus this 2a b over 2a squared, and then on the right it should be like something what I don't care about that. We just say this is the term, and then taking the square root, you have to remind yourself to place that plus and minus sign, and then square root of b over 2a squared minus c over a, and then we just minus b over 2a on both sides, and we get this. If you simplify this, or you just taking the same denominator, then I guess you can have that the general quadratic formula. Yes, and I know some of the European students have been talking about this method as the PQ method, but I'm not sure how the origin of the proof of the PQ method. So I just I lay down all my proofs here and see if you guys enjoy the proofs, and if you guys get some intuition about how we can do this not very traditional way of completing the square. And I guess the main thing here I want to illustrate is that because the halfway distance, what we call the b, and the midpoint, the a, share the same value, and that is why I guess my method could be somewhat more efficient when we are talking about the derivation of the results. So, but this is only my opinion, of course. If you have your I don't know how you think. Um, if you have something some opinion on my way of thinking, then I guess you're welcome to comment in the comment section. And that's all I want to say. Um, Actually, you can also discover some similarities between my proofs and Dr. Po-Shen Loh's proof, because he is using the sum of roots to derive his results. But the sum of roots actually have some sort of connection to the taking x out this method. There is some connection. If you are dealing with a graph, you can easily see the connection between my method and his method. But then I don't do the whole result again for you. You can just try your proof. You can just try on your own. So that is what I want to say, and thank you for watching my video, and see you next time.